Hello third year, welcome back to Online Learning with Miss McPherson. Yes, it's me again. I'll be narrating all your lessons. I'll be bullying you all on Teams page, telling you to get your assignments done, your homework submitted, get the lessons watched. Do you have any questions? Welcome back. I hope you all had a lovely Christmas and New Year and that we are all feeling well rested and ready to kick off a new term. Now, since it has been a few weeks since we looked at any chemistry at all, we are going to kick off this new term with some revision on bonding. So, our learning intentions for today are to describe the structure of the atom, to define the term molecule, and explain the difference between covalent and ionic bonds. If you are successful, you will be able to describe the structure of the atom and the different subatomic particles, explain how molecules are formed, and explain the role of electrons in forming covalent and ionic bonds. Now that last one is the biggie. So, in order to explain the role of electrons in forming covalent and ionic bonds, I think we are going to have to go right back to the beginning and lay out everything that we already know about electrons. So, the first time we ever heard of an electron is when we looked at atomic structure way back at the start of this unit. So, an atom has two distinct areas. It has a nucleus in the centre and it has energy levels around the outside. Inside the nucleus, we have positively charged protons, and we also have neutrons which have no charge. We can call neutrons or describe neutrons as neutral. Our electrons, which are the focus of today's lesson, are inside these energy levels and they are negatively charged. So our atomic structure, negatively charged electrons, and energy levels outside the nucleus. The nucleus, which is in the centre of the atom, contains positively charged protons and neutral neutrons. So far, pretty straightforward. So let's think in more detail about electrons. We should already know that every atom has the same number of protons and electrons. This means that all atoms are neutral. Let's look at that in a little bit more detail. So this is a beryllium atom. In the centre of the beryllium atom, you can see 1, 2, 3, 4 positively charged protons, and around the outside we can see 1, 2, 3, 4 negatively charged electrons. Now, if we have 4 protons, each of those have a positive charge. In the middle of our atom, we have a 4 plus charge. Around the outside, in our energy levels, we have 4 electrons. Add them all together, that means we have 4 negative charges in total. Now, if you were to add 4 and negative 4 together, you would get 0. What that means is this atom, and all atoms for that matter, have no charge. They are neutral. And the reason that they are neutral and have no charge is that they have the same number of protons and electrons. Let's let that settle for a sec. And let's move on. So, from previous lessons, we should also know a little bit about electron arrangements. Now, each energy shell or energy level, I will go backwards and forwards on how I refer to them. Now, each energy level has a maximum number of electrons that it can hold. For the elements number 1 to number 20, for those of us who do not have their data books handy, that is from hydrogen all the way to calcium. Shell number 1, which is the energy level closest to the nucleus, it can hold 2 electrons. Shell number 2 can hold 8, and shell number 3 can also hold 8. What we are looking at right now is the electron arrangement for one of the noble gases. Do any of you know which one it is off the top of your head? We're going to run into it in a little second, so if you do not know, get out that data booklet, you will need it for the next slide. Elements which have full outer shells can be described as stable. This means they are unreactive and are not likely to form bonds because they simply do not need to. So noble gases are those elements that have complete outer shells. I'm going to highlight them in red for you right now. If you do not already have your data book out and at page 6, I advise you get it out. It's going to be helpful for the rest of our lesson. Now this full outer shell that helium and neon and argon and so on have makes them very, very stable and very unreactive. Now, all of the other elements that are not noble gases, they don't have complete outer shells. They have incomplete outer shells. This means that they, compared to your noble gases, are unstable and reactive. So, I guess the question that we are trying to answer today then is, how can other elements become more stable? How can the other elements on the periodic table achieve that complete outer shell? Because that complete outer shell is the key to stability. The first way that we are going to look at today for achieving that complete outer shell is ion formation. So for those of us who are perhaps not too clear on what an ion is, atoms can either lose or gain electrons to form charged particles called ions. So atoms, as we explained before, are neutral. Ions are charged particles. I'll go into a bit more detail. This is lithium. Lithium has an atomic number, highlighted in red, of 3. This means that inside the nucleus there are 3 protons, the nucleus being this little black circle in the middle. There are 3 protons, and in the energy levels outside there are 3 electrons. 1, 2, 3. Now, lithium is quite unstable, and it's quite unstable because of this outer electron. It would quite like to look like its nearest noble gas, helium. Helium only has 2 outer electrons and is very, very stable. In order to become more like helium, lithium has to lose this outer electron. Oh, wee technical issue. Oh, there we go. So, in order to do so and become stable, it loses this outer electron. Now, in doing so, there's a slight consequence. So, in the nucleus, we have 3 protons. That is not changing. We still have 3 positive charges in the centre. Rather than having 3 negative charges on the outside, we now only have 2. So if we do 3 plus negative 2, it's the same as saying 3 take away 2. Our answer is 1. So our lithium ion has a charge of plus 1. It still has the same number of protons. The number of neutrons hasn't changed, but it has lost an electron. And because it has lost an electron, it has a positive charge. It is now much more stable because it has the same electron arrangement as its nearest noble gas, helium. So, metal atoms lose electrons to form positive ions. Repeat it with me. Metal atoms lose electrons to form positive ions. If we have not got that written down somewhere, pop it in your jotter, pop it on a clear space on your white notebook. Just make sure we have it written down somewhere. So that's us covered metal atoms. Alright, let's have a look at fluorine. So, fluorine, it has an atomic number of 9, which means inside this nucleus it has 9 protons, and outside in the energy levels it has 9 electrons. 7 of those electrons are on the outer shell. Now ideally, fluorine would like to have 8 electrons in that outside shell, quite like its nearest noble gas, neon. In order to be like neon, it has to gain an extra electron. Now when it does that, it still has 9 protons in the nucleus, but in its energy levels it now has 10 negatively charged electrons. When we add those numbers together, we get 9 minus 10, which is negative 1, which means that our overall charge on our fluorine ion is minus 1. Non-metal atoms gain electrons to form negative ions. Say it again with me, folks. Non-metal atoms gain electrons to form negative ions. So, metal atoms lose electrons, they form positive ions, and non-metal atoms gain electrons to form negative ions, like this fluorine here. But wait a wee minute, where did that electron come from? We can't just pull electrons from nowhere. And that is where ionic bonds come in. So ions are formed during chemical reactions. When metals and non-metals react together, a metal atom donates or gives away electrons to a non-metal atom, and a non-metal atom will accept electrons from a metal atom. Let me show you what I mean. So here we have lithium again. Lithium with its 3 electrons, one of which it does not want. And here we have fluorine with its 7 outer electrons, and it is desperate for another one. So here is what happens. This outer electron that lithium doesn't want is donated to fluorine, which accepts this extra electron, and we form a positive lithium ion and a negative fluorine ion. So we have our positive lithium and our negative fluorine. Now, positive and negative are opposite charges, and opposite charges attract each other. So when lithium gives up its outer electron to fluorine, it becomes a positive ion, and fluorine accepting that electron becomes a negative ion. These oppositely charged ions become attracted to each other, and it is that attraction which is the ionic bond. So an ionic bond is the electrostatic force of attraction between positive and negative ions. And that word electrostatic just means an attraction between oppositely charged particles. So an ionic bond is the electrostatic force of attraction between positive and negative ions. Ionic bonds do not just exist between one positive ion and one negative ion. Thousands of ions will come together in this large repeating structure, which we can see here, called a lattice. So in a lattice, if we pick out, let's pick out this positive pink particle in the middle here. Can we see that it is surrounded by these big green negative particles on all sides? So up, down, left, right, it is completely surrounded by negative ions. And if we pick this negative ion down below it, it is surrounded by positive ions. And each of these lines is representing one of those forces of attraction between positive and negative ions. So let's go back a little second. An ionic bond is the force of attraction between a positive metal ion and a negative non-metal ion. That attraction between the opposite charges is an ionic bond. Ionic bonds form lattice structures. Compounds formed by ionic bonds form lattices are formed by ionic structures, and in lattices, positive ions are surrounded by negative ions, and negative ions are surrounded by positive ions. What you can do now is you can go to page 3 of your notes and complete them for me. So pause the video here, complete the notes. So how can elements become more stable then? That was a question we were looking at to start the middle of this lesson. The first way that we've looked at is the formation of ions and ionic bonds. So we've looked at metal atoms giving up electrons and non-metals accepting those electrons, becoming positive and negatively charged, and those opposite charges forming a bond. Now, the second way that we are going to look at is the sharing of electrons. So in this example that we're going to look at, there's no giving and taking of electrons, but instead they are sharing electrons. So non-metals can't donate or give away electrons to other non-metals. So what they have to do instead is share. And this is how covalent bonds are formed. So this is hydrogen. We have its nucleus in the middle and its lonely electron on the outside shell. So it's hydrogen. This is also hydrogen. The only difference is I've chosen to draw the electron as a cross rather than a dot. That'll be important in a little minute. So this is hydrogen, this is also hydrogen. Here and here. Now, hydrogen, quite like lithium, would also like to have the same outer electron arrangement as helium. So it doesn't want one outer electron, it would like two. Now, this hydrogen can't go up to its neighbour and say, I would like your electron, please give it to me. They have to share it instead. So what happens is, sorry about that, their outer shells cross over, as we can see here, and they share this pair of electrons between the two atoms, and it forms what's called H2. It's a molecule of hydrogen. Stop a wee minute. Let's think about it. How does that actually work? to understand it, we're going to go back again to our trusty diagram of the atom. So, we've already established today that positive and negative charges are attracted to each other. Now, electrons, which orbit around the nucleus in their energy shell, so they're constantly moving around the outside within their shell, and they are held in that shell by the protons. So that positively charged proton is attracted to the negatively charged electron, it holds them in place, and it holds the atom together. Let me show you. So each of these electrons we can see is attracted to the protons, and each of the protons is also attracted to the electrons. Sorry guys. This is important for covalent bonds. So, in an atom, it's held together by that positive charge in the nucleus, holding on to the negative electrons. And if we have a closer look at what's going on in that covalent bond between the two hydrogen atoms, this is what we see. We have a positive proton in the nucleus of each hydrogen atom, and we have negative electrons shared between the two. So each nucleus, each proton is attracted to its own negatively charged electron. However, it's also it is also attracted to the other atom's electron. So, the protons are attracted to electrons from its own atom and electrons from the other atom. A covalent bond is the sharing of electrons in non-metal elements. The official definition for a covalent bond is the electrostatic force of attraction between positively charged nuclei and negatively charged shared electrons. So in a covalent bond, the nuclei, the protons in the middle, are attracted to the electrons of their own atom and the electrons of the atom that they are sharing with. And that attraction is what is holding these two or potentially more atoms together. So, take a breath, take a breather. It's a lot to take in a really short lesson. I appreciate that. It's a lot to take in, especially if it's not familiar to you. Here's something that might be slightly more easier to wrap your head around. A molecule is formed when two or more atoms become chemically joined. And we already know that saying something is chemically joined is the same as saying it is bonded together. We can have molecules formed from the same element. For example, here we have two hydrogen atoms that have come together. It's a molecule of hydrogen, because from our definition, a molecule is formed when two or more atoms become chemically joined together. So we have a molecule of hydrogen, but because it's two hydrogen atoms together, we can still call it an element. The same would go for two oxygen atoms bonded together. It is a molecule because it's two or more atoms joined together, but as they are the same element, we would still call it an element, not a compound. Compounds are formed from two or more different elements. So water, for example, would be a compound. It is formed of one oxygen atom in the centre and two hydrogen atoms at the sides. So molecules are formed when two or more atoms become chemically joined. These chemical joins are called bonds. Molecules can be formed from atoms of the same element, for example, hydrogen and oxygen. It's still called an element. However, when we have two or more different elements, like in water, where we have oxygen, this red one, and hydrogen, in white, we would call that a compound. What I would like you to do right now is take a little breather, take a breath. There's a lot of information that's going into this slideshow. Have a read and highlight at the first 5 lines of notes on page 4 of your white notebook. You'll either have, hopefully, a physical copy of that or an online copy. I don't mind which you use. Highlight, annotate, make it make sense to you. Before I leave you, I am going to go back to our success criteria. So I would like to think that you can describe the structure of an atom and the different subatomic particles, that you can explain how molecules are formed, and you have at least a basic idea of how electrons are involved in forming covalent bonds and in forming ionic bonds. Now, later on in the week, Mrs. Grimes and I are going to make ourselves available for a live chat where we can answer any of your questions that you have on this. If you don't feel comfortable asking your questions out loud, or typing them in and leaving a comment, or asking on a live chat, what you can do is you can either email myself or Mrs. Grimes your question, and we will answer those at the kind of live session later on in the week. As always, guys, any questions, fire them my way. Ask Mrs. Grimes. We are all available to answer any questions you have, and I hope you have a safe and lovely rest of the week. Bye, guys.